Hello everyone. So previously we had discussed on the topic 01 knapsack algorithm, right? So today we'll be discussing on the topic unbounded knapsack algorithm or the problem, right? So what is unbounded knapsack here? See here, I'll just read out the question loud. So just listen to this carefully, right? So given n item types, sorry, each with a weight and value. So each item consists of the weight and value and the knapsack capacity W, right? So we need to choose the items. Each item may be chosen unlimited times. We don't have any restrictions here. Each item may be chosen unlimited times so that the total weight is less than or equal to W and total value is maximized, right? So this is typically solved with the dynamic programming or the bottom up n because of n into W time, right? So that's what this is one of the famous or the this one famous DP problems of the algorithm. If you have usually would have heard about it, right? So this is fine. Let's move on with the explanation part. Unlike 01 normal 01 knapsack, right? So the previous one that we discussed, this one, unlike 01 knapsack where each item can be taken at most once, in unbounded knapsack what happens, we can take any item multiple times, right? Here in the normal 01 knapsack where each item can be taken at most once, only once, exactly once actually, right? In unbounded knapsack we can take any item multiple times, right? So what we will do here, we will keep let dp of w be the maximum value achievable with the capacity exactly w, right? So base case will be dp of 0 will be kept 0, right? So this is fine, I believe. For each capacity w from 1 to w, we will try every item I with a weight wt of I. If wt of I here, if it is less than or equal to w, candidate value is equivalent to dp of w minus wt, weight of I plus value of I, right? So we'll set the dp of w equals max of w, this one dp of w comma candidate. So this one will be making use of exact same thing within the code, right? So just listen to this. You don't have to understand everything in the theory. The implementation and what are the things that we need, that you have to know at any cost, right? So this is fine. This 1D bottom up, this one DP naturally allows reusing the items because when calculating DP of W, we may use the DP of W minus weight, this one WT, which itself may include item I already, right? Which itself may include item I already, right? Optionally, we can store this one keep of W array as well, just to reconstruct which item was chosen last for the capacity W. Let's see the same thing rather than more theoretical part. Let's see the same thing within the algo, right? Let's start writing the algorithm. I'll just make use of the Python programming language, right? So this is fine, I believe. First, let me tell you certain things here. So we are going with a unbounded knapsack, right? So I'll just go with a this one. What do we call? Let's implement the DP solution here. So this is completely based on dynamic programming itself, right? So we are going with the, or we will be going with a bottom up 1D DP. Just remember this, and we have to reconstruct the chosen items accordingly with what we had discussed in the this one explanation part, right? So let me consider example inputs here, weights, values along with the capacity. So I'll just go with weights that is equal to 2, 3, 4 respectively. And next, let me go with the values here. This one 15, 20, as well as the 30. So W I'll just keep here 7. Yeah. Weights, values, as well as the, we'll be going with the capacity, right? Capacity is nothing but the this one big W, whatever I have used here, the capital W. So that I have initialized to 7, nothing but capacity of the knapsack. It is the capacity of the knapsack. Next, let's go with the number of distinct items. So this one will be, yes, and this one length of weights actually. Yep, this is fine, man. Now, so let's go with the dp of W that holds the maximum value achievable with the capacity W. So I'll just go with dp. This is nothing but the dp initialization 0 into capacity plus 1, nothing but sorry, this one W plus 1. Yep. Now, let's go with a keep variable, right? Keep of W that will store the index of the last item that is used to achieve the dp of W. Let's initialize keep in simple terms. I'll just go with -1 here, W plus 1. This is fine, I believe. Next, what shall we do? Let's build the DP table iteratively for capacities from 1 to W. Again, let's build the DP table iteratively for capacities from 1 to W, right? So this one will be for WN. Let me go with capital W here. For WN, have used this one for the capacity, right? So this is fine. For WN, range from 1 to capacity plus 1, nothing but. Now let's make use of the capital W here. Next, let's go with a one more for loop here. Let's try this one every time, right? So we are just going with the unbounded usage. Here, unbounded usage allowed, right? So unlimited times we can make use of. So this one, let me go with for I in a range of this one, N actually. This is fine. Within the for loop, first let's go with the weight of the item I and value of the item I. So this one weight equals uh, weights of I. So this one will be weights of I and value equals, so this one values of I, right? Values of I. So this is fine. Next, if what if the item fits in current capacity, meaning I'll just go with if weight less than or equal to W, less than or equal to W. Then if taking the item I improves the value, then we have to update the DP of W and record the item. So I'll just go with the candidate here. Where is candidate? So let me make use of the candidate. Sorry, candidate equals dp of w minus weight. So this is fine. Plus the keyword value, right? So if candidate, if can sorry, yeah, if candidate is greater than dp of u, so dp of w, small w we have to use, right? Not u basically. What happened to this one? Yeah. If candidate is greater than dp of w, then let's assign dp of w to candidate. Simple. Yeah. Then let me go with keep of w equals 1. Sorry, I actually. Yep, this is fine, man. Now, this is it for the main algo. Let's do one thing. Let's go with the dp of w, that is maximum value achievable with full capacity, right? So let's print that. I'll just go with the print statement here. Print. So let me give here maximum value it. So this is fine. Let me pass dp of capital W, right? So this is fine one. Now let's do one thing. Let's reconstruct which items were used to achieve the maximum value, right? So I'll just go with the result items. This one equivalent to array capacity equals W. So this is fine. Next, while capacity is greater than 0 and keep here this one of CAP. If it is not equal to -1, then what we should do? Let me assign index to this one. Keep of capacity. This is fine. This is nothing but item chosen at the capacity CAP. The line number 45 I'm speaking of. Line number 46. Next, now what we have to do? Let's record the item index, meaning I'll just go with the result items. This one dot what we need to append to the result items actually index, right? So I'll just give here idx we have made use of. So let me pass this one here. So finally, let's reduce the remaining capacity accordingly, right? I'll just go with the capacity equals capacity minus weights of what we need to pass index, nothing but idx, right? So now this is fine, man. Now let's do one thing. Let's convert the item indices to the weight comma value pairs for the readability purpose. So I'll just go with the result pairs here. I'll just go with result pairs. So this one equals, what's the pair we will be going with? So I'll just go with here weights of I comma values of I, values of I. So this is fine. Weights of I comma values of I actually. As well for I in result items. So I'll just go with the result items, right? So this is fine. Let me give print here me go with the chosen items here. Chosen items. So this one will be weight, comma, value, weight, comma, value in selection order. In selection order. So this is fine. Next, finally, what I need to pass here basically, we have to display the result pairs, right? So I'll just give your result pair, this one. Yep, this is fine, man. Uh, we are just converting the item indices to the weight value pairs for the readability. Next, let's do one thing. Let's go with the print statement again for the this one interactive purpose. Let's give print or let's print full DP table to explain the intermediate results, right? So I'll just go with print here. So this one will be DP table. Uh, we have to go with the capacity, right? So I'll just go with capacity here. This is fine. Let me give max value. Let me give here max value. This is fine. Yep. The next part would be, let me go with a for loop for I in range. For I in range, uh, W plus 1. So this is fine. Within the for loop, let me go with print of this one I, comma, this one, comma, dp of I actually. Yep. Yeah, this is it for the code actually. This is it for the code. Yeah. So, yep, this is it for the code. We have successfully completed the algo. So I have explained this one step by step. So now what is the output I need to get if I run the code actually? Yeah. What is the output that I need to get if I run the code actually? Uh, so let me explain you this part itself. So we have considered this input right here. This is fine. First thing is we are printing the maximum value. So the maximum value that we need to get here is 50 actually. The maximum value that we need to get here is 50 and chosen items. So let me explain this step by step. Why we need to get here is why we need to get here 50, the maximum value. We are printing the maximum value in the print statement, right? So with the capacity 7, so we are considering here capacity equals 7, W equals 7, whatever we have considered with the capacity 7, the highest achievable total value is 50. The highest total achievable value is 50, right? See here we have weights 2, 3 and 4 at 2, 3 and 4, right? So we can just go with a 3 and 4 capacity. We have 7, right? So here see, let me remove this one. Yeah, here either we can go with we cannot go with 2, 3 and 4, right? So we cannot go with 2, 3 and 4 because it will exceed 7. We have capacity 7 here, right? So we can just go with 2, 3 2, 3 or 2, 4. 2, 4 will give us actually 15 plus 30, that is 45, and 3 4 2 3 it will only give 35, right? 15 plus 20, and 3 4 will give us actually 20 plus 30, 50, right? So with the capacity 7, the highest achievable total value is 50 here. So that is the reason maximum capacity first 50. That is the output that we need to get. Then the chosen items weight comma value pair in the selection order basically, right? So this has to be 2 comma 15, 2 comma 15, this one and this one. Second 3 comma 20 and 4 comma 30, right? So this one, oh, we are going with this one, right? We are going with the chosen items actually, weight comma value in the selection order actually. So this one has to be 2 comma 15, 2 comma 15 itself. Then we have to go with a 3 comma 20. Then we have to go with a 3 comma 20. So why are we considering this one here? We are going with a this one reconstructed selection here that shows the algorithm chose the item of weight 2 twice. Weight 2 twice means this one, the first one, weight 2 twice means 15 15. Again we have considered, see here, 215 and 215. So the reconstructed selection shows the algorithm chose item of weight 2 twice and item of weight 3 only once. So this one 3 and 20, so this chose it was chosen only once. So total weight we have to go with only weight if we considered weight. So this is 2 actually, and this is also, it consists of only 2, right? So this is also 2, and this one we have 3 here. So this one will be 2 plus 2 plus 3, that will lead to 3 4 5 6 7 actually. 3 4 5 6 7. So total value would lead to here 15 plus 15 plus this one, what do we call, 20, that is equal to 50 itself. That is equal to 50 itself, right? So let me write it over here, 50. Yep. So now chosen items weight comma value in the selection order, we have to get the output 2 comma 15, 2 comma 15, and 3 comma 20. This is fine. Next, what we are doing, we are displaying the dp table, right? Capacity and the maximum value, basically capacity and the maximum value. So let me show the dp table. So here, let me delete this one now. Let me delete this one. So here now we have gotten this one. We have got this one idea on this one, and we have got the idea on this one as well. What we are printing, basically first one, maximum capacity, actually this maximum value, sorry, this one, line number 40 and line number 50. This we have got the idea. So this we are printing, okay. And one more thing, we are printing this one as well, dp table as well, capacity to maximum value. This one also we are displaying, right? So uh, basically let's go with this one. Let me show you this one entirely. So this one, so let me show the dp table rows, actually. Let me show the dp table rows, actually. Yeah, this is fine, I believe. So capacity to maximum value we are displaying. So this one, first initially it will be 0 to 0. Why it is 0 to 0? Capacity 0 gives 0 value. So this is the base case. So we are making use of the DP. Capacity 1 gives 0 because capacity 1 cannot fit any item. So value is 0. Capacity 1 cannot fit any item here. We have 2, 3, 4, right? So this will be 0 itself. Yeah. Next, we will be going with the 2. 1 to 7 we have to consider when we consider the DP, right? So 2, we have the value of 15. See here, 2 for the weight 2, we have the value 15 here, right? So 2 we will be considering 15. Best is take the weight 2, this one, this one, 2 item once, actually this will be 15. So this is fine. Now we will be considering 3 we are having the value 20, so we can just write it in this way, 3 20. So best is take weight 3 item once, nothing but 20 here. This is fine. Next, let's go with a 4. 4 we can take 30, right? So 4 we can take 30 here. Best is either take 2 weights, nothing but the 2 items, nothing but we can just take this one, 2 comma 3 and 2 comma 3 twice, right? So we can sorry, 2 comma 15 and 2 comma 15, I'm sorry, this one, 2 comma 15 and 2 comma 15 twice. This one, best is either take 2 weights, nothing but 2 comma 15, 2 comma 15, nothing but 15 plus 15 twice here, or one weight itself, nothing but weight for this one, 30. We can either consider 2 comma 15, 2 comma 15, nothing but 15 plus 15, or we can just consider 30 directly, right? Nothing but the weight, one weight on fourth item, right? So that is nothing but the 30. Both give us 30 itself. Either we can take this one 2 twice, actually that will also give 30 itself, right? So we can either take that one 2 twice, or we can just take 4 once, nothing but the 30 here. Next, 5, 5, next we have to consider 5 because capacity is 5, right? 5, for the 5 we will be going with a 35. Why 35? You can ask how it is 35, because best is weight 3. So this one we will be considering, actually 3 which is having the weight 20, and the weight 2 which is having the this one, what do we call, 15. So this one, when we sum up, actually it will be 2 plus 3, we are summing up, actually nothing but in this case it will be 20 plus 35. 20 plus 20 plus 15, sorry, it will lead to 35. It will lead to 35, this one. Yeah, now I hope this is clear. Next, we have to consider the capacity 6, actually 6, this one will be 45. So best is what here? In this case, best is 3 weight, 3 actually, 3 meaning 3 weights, nothing but the 2 items. So this will be 15 into 3. So this one, 15 into 3, 45, or we can just go with a weight 3 twice, nothing but 20 into 2, 40. 20 into 2, 40. So this one, we can either consider 2 or 3. So this will be 50, 15 into 2 or 20, 15 into 3 or 20 into 2. So it will be either basically it will be 45 or 40, right? So let's consider this one, maximum we have to consider, right? So we will be considering 15 into 3, actually. So this will lead to 45. Yeah, we have considered 15 into 3. Weight 2 thrice, actually, right? This is fine. Yep, this is fine. Now we are left with only the seventh part. So this one will be this one will be 50. How it is 50? So the final capacity 7 is the best. Final capacity 7 is best, actually. We will be going with 2, 2 as well as the 3 ones. So 2, 2, 2 we are having value 15, and nothing but 15 plus 15. 2, 2, and 3, as I've said. 3 is nothing but the 20, right? So this one will be 15 plus 15, 30. 30 plus 20 is nothing but the 50, right? So this one will be 50. So this one will be 45, right? So this is fine. So 10, 15, 20, 30, 35, this one 45 as well as the 50 is the output that we need to get here for the this one capacity max value where, right? So this is what the output that we need to get when we run the code actually. So let me copy this one entirely. Yeah, so let me give control J here. Let me give Python followed by filename.py. So see here, maximum value that we got is 50 that we have discussed, and the chosen items, this one weight comma value in the selection order. So we have discussed this one as well, 2 comma 15, 2 comma 15, 3 comma 20. This is correct actually. DP table capacity to the max value. So we are getting 0, 0, 15, 20, 30, 35, 45 as well as the 50. So we have got the desired output as discussed earlier. Just now we discussed, right? So this one. So we are getting the desired output. So now we are done with this particular algorithm, unbounded knapsack algorithm, right? So before moving on with the next algorithm, let me summarize whatever we have learned so far, right? So first thing, unbounded knapsack problem, what it does, it maximizes the total value. It maximizes the total value with unlimited copies of each item with unlimited. So this unlimited word is very important. With unlimited, this one copies of each item of a of this one with each item given a capacity W, capital W. This is fine. The next step here would be approach would be we will be going with a bottom up dynamic programming. We will be going with a bottom up DP, or the bottom up dynamic programming, with DP of W is equivalent to the best value for the capacity W. That's what we went with, right? So complexity would lead to overall time complexity would lead to big of n into W, big of n into W, and the overall space complexity would lead to big of capital W, right? Nothing but the capacity actually, space. Right. So this is fine. Next, let's move on with the third important point. So here, let's discuss the reconstruction part. When I say reconstruction, we have to keep track of the last item that is used for DP of W to rebuild the chosen items. Yeah. So I'll just mention this one, reconstruction. Yeah, this part. So finally, let's discuss something. So computing DP of W within the algorithm that we have written, computing DP of W from the smaller capacities, it allows items to be reused, right? So in this case, using 1D DP. So we are making use of the 1D DP itself, bottom up approach. We are using 1D DP is efficient and standard for the unbounded knapsack. Unbounded knapsack. Yeah, these are some of the important points that I wanted to discuss with you guys. So we are done with the this one, this particular algorithm, unbounded knapsack algorithm. Right. So next we will be discussing on the topic, this one, subset sum or the partition algorithm. Right. So for now, this is it. Thanks for watching, guys.